Chapter 7, number 14. A force F equals 4x I hat plus 3y j hat newtons acts on an object as the object moves in the x direction from the origin to x equals 5 meters. Find the work W equals integral of force times the derivative of r done on the object by the force.
So in this problem, we're given the force, which is equal to 4x I hat plus 3y j hat newtons, and I hat is the vector in the x direction, and j hat is the vector in the y direction. And we're also given the initial condition that it starts at 0 meters and it ends at 5 meters. So in this problem, we're asked to find the work done on the object by the force. So we can use the equation, work is equal to integral of force times dr from I to f. And if you don't understand calculus, you won't understand this problem, but if you do, just keep listening. So then we can plug in the numbers to get work is equal to the integral of 4x I hat plus 3y j hat newtons times dxi, since the particle moves along the x-axis from 0 to 5 meters. And then we can change this so that it split them up into two integrals. So it becomes the integral of 4x I hat newtons times dxi hat plus 3y j hat newtons times dxi hat. And since the particle only moves in the x direction, it doesn't move upwards or downwards, we can say that the second integral is equal to 0 and plug it in, so we get the integral of 4 Newton over meters times x dx from 0 to 5. And if we plug in the numbers, we get 4 Newton over meters. We just integrate that to get 4 Newton over meters times x squared over 2 from 0 to 5. And if we plug in 5 and 0, we get 4 Newton over meters times the quantity 5 meters squared over 2 minus 0 meters squared over 2 to come up with the final answer of 50 joules.